maybe we will end off with the your time at Bell Labs. We spoke a lot about research and the DNA computer that you were at least conducting experiments on, and maybe you could speak to people, let people understand like why was Bell Labs so special. Like, what made it special, at least during the time you were there, and do you still have fond? I assume you still have fond memories of your time at Bell Labs.
Yeah, it was great. I was first there as a student. I was doing my PhD, and I spent a year working there. And I got there, and it reminded me of my PhD in that they pretty much gave you a room and said, kind of go for it. There was no direction or we want you working on this project. And I noticed opposite my little office in that giant, completely windowless building was another little office that had a very strange looking, unusual looking computer in it. And I asked about it, and they said, "Oh, that's a Lisp machine." And I didn't know anything about Lisp or AI or anything, but someone there just bought, and these were customized machines that were built. The whole CPU architecture and everything was built in to just run the Lisp language. And they just had a Lisp machine there. So I just went in and started playing with the Lisp machine and taught myself Lisp and worked things out and started designing VLSI design tools using Lisp. And because this was a VLSI design, chip design department. So it's and that was my background. That was my PhD. And that in the end led to what I did in the PhD because they happened to have those machines just laying around and no one using them and everyone just encouraging them. It's like, oh yeah, just go play with it. Spend as much time as you want on it. I went back later for a full-time job after I finished my PhD in Australia and worked for an amazing guy called Alan Wong, who had this vision for building an optical computer. And it's a little, I think I channeled him a little bit when I was giving you guys the biological, the DNA computer pitch. Alan was like, it's ridiculous that computers run on electrons. It's like it's the worst way for a computer to run. And he would say things like, think of a computer, electron computer is like New York City. All the cars have to stop at the intersections because they all interfere. But if it was an optical computer, the cars would just pass through each other at all the intersections, and everyone would go, "Whoa!" And he was a very compelling, and he made all these arguments, and he convinced me. So I went back there to build an optical computer. I'm like, "Oh, electronic computers, that's ridiculous. I can't believe we're so backwards." So in parallel with working on that, just a vision or an architecture for a biological computer, that was just in a way a side project for me. The project we were all drawn to was to build an optical computer, which turned out not to be a great idea, for reasons I won't get into. But then I bounced back into chips and was really interested in the idea of the fact that chips were light sensitive. And back then, this is now the early 90s, that image sensors were all built in a process called, oh my God, I'm getting so old now, I can't remember the name of it. How funny. CCDs, charge coupled devices. And so your camcorder had a CCD in it, and it did a great job for that. But we were thinking, well, we had a lot of access to CMOS, like standard chip fabrication. Maybe we could build cameras that way. And Eric Fossum, who was at JPL, was really at the center of that activity, but also the University of Edinburgh. And so a lot of us started to work on the idea of building image sensors out of CMOS chips, which we got a lot of patents and turned into like every image sensor, ones we're using right now, they're all CMOS, right? It just in the end made perfect sense to integrate the electronics right alongside with the photosensors. CCDs couldn't do that. You couldn't build a transistor in a CCD process. And then that in turn, there was some security people at Bell Labs, because Bell Labs and AT&T were in everything, that were thinking of, was there a better way to build a fingerprint sensor? And I ended up talking to them, and they were like, well, you're building these really compact optical sensors. Maybe we can build use that to build a better fingerprint sensor, because, you're looking at a fingerprint. And somewhere along the way, we got the idea of, well, why don't we just get rid of the optical part and just put the finger right down on top of the chip and use the circuits inside the chip to measure the capacitance. Because if you're a chip looking up at a finger, sometimes you've got skin coming right down to the surface, and sometimes you've got a big valley as the skin on the valley in the fingerprint reaches away. And it turned out, I'll never forget it. We went and built that chip. And we went to the fab. It takes months. It comes back. We put it into the big test system, and I put my finger on it, and an image came out. I couldn't believe it. It worked like first time. It was just amazing. And that we filed the patent for that, I think, in '95, and that eventually ended up in Apple's hands and as Touch ID, which ended up in the phones for
Wow.
the first time. So I just give you all those just to give you some idea of the variation. We just wandered around and we did what we thought was kind of interesting and published papers. And we were measured not by our, I don't know, call it useful commercial output. We were just measured by, did you get some good publications in the last quarter? And are people being attracted to your work, right? That was a good thing. If you became a sort of a catalyst for effort, that was a really good sign.
Mm.
And right beneath me, far more historic, right beneath me, there was a group working on neural networks, and one of the lead people there was Jan LeCun, who's ended up heading up AI for Facebook, Meta, and being very famous in the field. Um, and we were like the chip guys. We thought they were kind of crazy down there. It's like because we couldn't do any math. We didn't have the vision, so we couldn't do any math where we thought that would ever be useful. It's like, yeah, it's cute. Like it's built like three neurons. Like, fun. So completely missed that one. I got to say.